Hi, welcome back to Numero Studio. In this video, we will talk about a statistical procedure that allows us to make intelligent forecasts and predictions on certain measurements. For example, on this table that relates birth weight and estriol levels of 31 pregnant women, there is a way for us to determine the line that best approximates the trend created by these points. We call this the line of best fit, and the line is described by the equation y equals 0.61x plus 21.52. This equation will allow us to predict the birth weight given any estriol level so long as it is within the range described in the data set. But first, a quick recap on the idea of a line. In geometry, a straight line can be described by the equation y equals mx plus b, where m is the slope. Recall that slope is the change in y over change in x. So, a slope of 2/3 means that for every increase of 2 in y, there is a corresponding increase of 3 in x. Now b is the y-intercept. This is where the line crosses the y-axis. So in the equation y equals 2/3 x plus 1, the slope is 2/3 and the y-intercept is 1. If we want to show its graph, we can start with the y-intercept at 1 and look for another point using the slope. So as y increases by 2, x increases by 3. And we can connect these 2 points and show the graph of the line. Now what if we are still given with the math and English grades of the 6 students we mentioned in the previous video, and we are interested in predicting the English grade of a student whose math grade is 86? This is a problem that requires linear regression. This is a scatter plot of the 6 points, and clearly there is a decreasing linear trend of the points. So the goal is to find the equation of the line of best fit and use it to predict the English grade. The first step is to find the slope using this formula. And we already have the values required from our previous work. We plug in these values into the formula and get m equal to negative 0.28 or negative 0.28 over 1. A good interpretation of this value is that for every decrease of 0.28 in English, there is a corresponding increase of 1 point in math. Next is the y-intercept, and we use this formula. Y bar is the average of the y values, or 512 over 6. M is the slope from the first step, and x bar is the average of the x values of 511 over 6. We plug in these values and get b equal to 109.18, accurate to 2 decimal places. With m equal to negative 0.28 and b equal to 109.18, the equation of the line is therefore y equals negative 0.28x plus 109.18. But how do we show this on the scatter plot? There are many ways to do it, and one of them is to look for the smallest and the highest values of x, which are 74 and 95 respectively, and plug them into the equation. So when x equals 74, y equals 88.46, and so we have this point. When x equals 95, y equals 82.58, and we have this other point. We plot these 2 points on the same scatter plot and connect them to show the graph of the line of best fit, which is y equals negative 0.28x plus 109.18. Now we can predict the English grade of a student with a math grade of 86. We simply plug in 86 into the equation and get an English grade of approximately 85. Using the same procedure, are you able to forecast the number of lymphocytes when there are 2.5% reticulocytes in this dataset? That's it for linear regression. Please like, leave a comment, subscribe, and hit the notification button to get notified for future videos. I'll see you in the next one.